Hello my dear friends, how are you? I believe all of you are doing well. Today we will start with combinations. So factorials done, permutations done. Next topic that is left with us is combinations. So in this video what we will be doing is we will be learning about combinations. It should not be very difficult because we have already learned factorials, we have already learned permutations. So combinations, we have already seen a little bit of combinations. What is the difference between permutations and combinations, right? So in this video what we'll be doing is we'll be just learning a little bit more about combinations, some of the very important theorems, and then of course in the later part as we start solving some problems on combinations, I will be sharing with you also a very useful trick on how to just find out the value of combinations without actually using its formulas. It will come in very handy, okay, especially when we solve big problems on like binomial theorems and its application based problems. So let's begin then. Let's start with combinations. So if you remember, while we were doing permutations, I think we found out the difference between what is a permutation and combination. So if you haven't, please go back and check out the videos on permutations. I will be giving you the link below, so you can just click on the link and then learn permutations. You just cannot start with combinations all of a sudden. So there we have learned that permutation is about arrangement and combination is about selection. So how do we differentiate with the problems? Examination time it will not be given up permutations and combinations. Of course, in the meantime, you can just write down this notes if you have, so that I can just keep on talking, so that you can also keep on writing, right? So as we have seen that permutation, how do we differentiate? That is by reading the question, and then when it's a problem of selection, then it will be based on combinations, and if it's a problem of arrangement, then it will be based on permutations. As we have learned that in combination, the order of arrangement is really not of a big concern. That's what it says, combinations. Each of the different groups or selection. For example, like selection in the football team, selection in the school choir. That's about selection. Whether you're selected in the beginning or in the last doesn't matter. You're still selected in the team, isn't it? Which can be formed by taking some or all of a number of objects, irrespective of the arrangement, is called a combination. Formula-wise, the number of all combinations of n different objects, distinct objects, different objects, unique objects, taken once at a time, r at a time, is given by NCR. This is the way we denote sometimes, NCR, C bracket NR equal to NCR will be equal to almost similar to permutation formulas, n factorial upon n factorial into n minus r factorial. Okay? Alright, so I'm grabbing this off. I think you have taken a note of this. Now, let's see some basic things about these combinations before we really start solving problems. Like, let's find out using the formulas. Let's see what do we have with NC0. Now what will be NC0? Now let's use that formula, that is n factorial by r factorial into n minus r factorial. So that will be n factorial, 0 factorial, I've already told you that's 1. So 1 into n factorial, n factorial, n factorial. So remember NC0 is 1. What about NCN? Let's see, n factorial, and of course same thing in permutations also. The same thing holds, that is, when you have NCR, this n value should always be greater than r, as it was mentioned in that theorem. No? N should be greater than 0, and r also should be either greater than or, of course, minimum. These are very rare cases when r is equal to 0, otherwise it's always like greater, but r cannot be greater than n. You know that, right? So then the n factorial, n minus n factorial, because the value of r is also n here. n factorial into 0 factorial, okay, 1 by 1. So NCN is also 1. One more. NC1. Please take out your books. Don't sit on the bed and then just watch the video. Keep on noting down. Let's do it together. n factorial, 1 factorial, n minus 1 factorial. These are very important stuffs, okay? I have told you before also, please do not. So n factorial I can write as n into n minus 1 factorial. Please do not ignore this chapter. It's going to be very useful. You are not going to regret studying this chapter. So NC1 will be n. Now based on this, I will be sharing some tricks very soon once we start with the problems. So these are certain things which next time when we come across, we will not be finding out, we will be directly using it, okay? Alright, now I'll give you some important theorems also today based on combinations. Theorems like number one, the first theorem that I'll be giving you would be NCR is equal to NCN minus R. Very useful theorem, this one. Actually they are called complementary. Okay, they are called complement. These two actually are called, of course, provided as usual R greater than 0 but less than or equal to n. Of course, that is always the condition. Or greater than or equal to 0, right? These two actually are called, these two values are called complementary combinations. Complementary combinations. Complementary combinations. That means these two, they complement each other. That's why they're called complementary combinations. And it's very useful. I'll give you one example like 36C34. Let's say 36C34. So this value 36C34 will be also, if you don't want to proceed with the calculation of 34, actually that will be what? 36 factorial by 34 factorial. Either way it's same, okay? 36 minus 34. But when we start using that shortcut trick which I will be giving you, then this formula becomes very handy. So that 34 factorial into 2 factorial. Right. Now if we apply this formula, so that will be actually what? 36C n minus r. So that is 36 minus r, 34. So that will be also same as 36C2. We may not find its use as of now, but as I told you, when you start using that shortcut trick that I'll be giving you very soon, this becomes very useful. So, but of course for verification you will see that this is 2 factorial, 36 minus 2 factorial, just for verification, just for your happiness, that you will not doubt this formula. So you will see that these two values actually are same, so which proves that the theorem, of course, is definitely valid. So this is one theorem. I hope you have noted down complementary combinations. All right. There are many more theorems which I will be giving you, but the other theorems will not be going for the proof because the proof is necessarily not required as of now. The second theorem that I will be giving you, which is again going to be useful, is NCR plus NCR minus 1. NCR plus NCR minus 1 can be composed as n plus 1 CR. N plus 1 CR. Alright, that is, for example, if you have 5C4 plus 5C3, NCR, R is 4. Next, NC, 5C, 4 minus 1, 3. So if you get any arrangements like this, if you get any sequence like this, then that can be simply, n should be same, of course. That will be 5 plus 1 C. What was the value of R here? 4, isn't it? 4 minus 1, 3. So 4. So that will be 6C4. Alright. We will very soon get to see where we use all this. Okay? Alright, I am wrapping it off. The examples. Theorems are lengthy for some moment. Another theorem that you can note down will be n into n minus 1 CR minus 1. This, of course, in NCERT I haven't come across where we usually use this, but it's not only about the NCERT, it's about the JEE examinations, competitive examinations also, where we will be definitely using. So n into, if you come across, this can be expanded in this form also, that is n into n minus 1 CR minus 1 will be also n minus R plus 1 into n CR minus 1. Another theorem will be NCR, the ratio. NCR, this one if you know how to apply, we can use it everywhere. NCR minus 1. R minus 1. Yeah. yeah, NCR minus 1 can be simply, of course, if you calculate, this is actually a proof also. If you calculate, you will get this proof. But especially for like competitive examinations and all, we don't have time for calculating all this. So if you can just get the sequence, directly you can just use these values. Alright. Of course, for these two theorems, the condition is that R should be greater than or equal to 1. Of course, always less than or equal to n. R should not be 0. Alright. So these two theorems, maybe not for board examinations, may not be very useful, but definitely for your competitive examinations and all, it will come in very handy. Okay, it's going to definitely come in very handy. NCR minus 1 equal to n minus the ratio. No, the ratio will be simply without calculating directly. I mean n minus shortcuts, n minus r plus 1. Of course, n and r should be positive integers. All right. So the 1, 2, 3, 4. Then another theorem that I'm going to give you, which is again also very, very useful. That is, here comes, if NCP is equal to NCQ. If NCP is equal to NCQ, then definitely it does imply that P will be equal to Q. That's for understood, already understood, right? P equal to Q. But if P is not equal to Q, then P plus Q, of course, should be equal to N. Now, what is the purpose of this? What do you mean by this? You will soon come to know about this. That is, like, if P is not equal to Q, alright, then in that case, P plus Q will be equal to N. These are the only two conditions. NCP equal to NCQ, that means like 36C2 should be equal to what? 36C2. Understood. P should be equal to Q. But you remember the second theorem, I think, yes. Second theorem that I gave you today, not the first theorem that I gave you. There is another way of writing this 36C2 also. What was that? It can also be written as, that means P plus Q if it is N, then if P is 2, Q, N is 36, then Q is what? 36 minus 2. That is 36 minus 2. That's what we call it complementary. So that is actually what? 34. So that means P plus Q should be equal to N if P is not equal to Q. So it just complements our first theorem only. Okay, but quite useful in calculations. Alright, now with that said, there will be definitely plenty more theorems. Let's just try to evaluate some of the combinations, practice before we really jump into the exercise. That's what we usually do, isn't it? Get used to combination before we really jump into the exercise, because as I've said, NCERT usually doesn't provide us enough practice problems, so we will try to provide, okay? Which is definitely not going to be enough, of course. 100C97. Let's calculate this value. That one, of course, let's just use the formulas. 100 factorial, n factorial by r factorial into n minus r factorial. So that's going to be 100 factorial, 97 factorial. This 100 factorial, then I'll just expand because I have this 97. So 100 into 99 into 98 into 97 factorial. And of course this will be 3 factorial. So that's 100 into 99 into 98 by 3 into 2 into 1. So 333 2150. Can you calculate that for me, please? So that should be 50 into 33 into 98. So that gives us 16170. So that's just the way of calculating combinations, just a mathematical part. Now, chalo. Done? Okay. My dear students, please do study well. Time is running out. Okay. Time is running out, so please do study well. The year is almost ending, so please give more importance to your studies. Of course, it's kind of difficult to get motivated on our own. No, we need a source to be to motivate ourselves, but we have to find out a way. Otherwise, who really cares about what you do, right? We have to take care of ourselves. So it's all about how much you value your life. It's all about how much you value your life, how much you value your dreams. So please rethink about that, and then again wake up. Come on, don't be lazy. Start studying. Pick up the book. It's difficult, I understand, but this is what we have to do. Now, remember that last theorem which I gave you, that is like, if this is the solution. If NCP is equal to NCQ, then that implies P is equal to Q. But here what happens is, and if P is not equal to Q, then here P is not equal to Q. Isn't that? 14 is not equal to 16. Then in that case what? Then P plus Q is equal to N. So the question is, if NC14 is equal to NC16, find NC28. Find NC28. Now to find out NC28, I need N. And that N I will find out from here using this theorem, because NCP is equal to NCQ. When that can happen? Only when P is equal to Q. But here P is not equal to Q. 14 is not equal to 16. But we also know that if P is not equal to Q, then in that case, again the complementary, then P plus Q should be equal to N. Then we just studied that theorem previously. Then in that case, N is P plus Q, that is 14 plus 16, that is N is how much? 30. So now since we have our value of N, we can proceed. So NC28 will be 30C28. So that's 30 factorial by 28 factorial, 30 minus 28 factorial. So like 30 into 29 into 28 factorial. 28 factorial into 2 factorial. 28 factorial, 28 factorial, bye bye. So what do we have? I'll just calculate here. Oh sorry, let me just finish the factorial also. 30 into 29 by 2 into 1, 15. So 29 into 15. 29 into 15, that's, we'll get 435. So I believe you are getting a hang of this combination slowly now, just the use of the formulas and the theorems. Okay, are you done? I'm rubbing it off now. Okay, another problem. Let's see. Another exercise, that is if. What do we have here? 2n twice NC3 is 2. NC3 is 11 is to 1. Then the question is find n. Chalo, let's solve. That is solution. No easy way to this. Please hold on. Okay. As I told you, I'll be giving you a shortcut trick to directly compute the value of combinations, but not without knowing exactly what is combination. So let's see, how do we really do combinations, which we are already learning. What is combinations? How do we expand? Okay, once we know that, after that, chalo, we can apply the trick, which we know how it comes, isn't it? So let's solve this. 2nc3, that is n factorial. What is n value here? 2n. No? N upon r factorial n minus r factorial, all divided by n factorial, again 3 factorial n minus r factorial is equal to 11 by 1. Okay, alright, then let's simplify this. 2n factorial 3 factorial 2n minus 3 factorial into reverse 3 factorial n minus 3 factorial by n factorial is equal to 11 by 1. We will take it step at a time. 3 factorial gayab. Now let's see what we can expand. 2n minus 3, 2n. I think we can expand 2n to get 2n minus 3. So let's expand. That will be 2n minus 1, 2n minus 2, 2n minus 3 factorial into n minus 3 factorial also, right? 11 by 1. I hope you can see that, yes. And okay, 2n minus 3 factorial. I'll expand n factorial to reach n minus 3. So n minus 1, n minus 2, n minus 3 factorial. So this factorial goes, because as long as we have the factorial, we cannot simplify it, we cannot solve. No, that's a problem. Alright, now let's sort that out. That's 2n minus 1. I'll take 2 common there, n minus 1. Okay, no problem, I guess. Because these are all multiples only. N minus 1, n minus 2. Remember, mathematics, as I always tell you, our job is not to make the problem complicated. Our job is to make the problem simpler. Life is very simple. Don't make it complicated, my dear students. It's us who make it complicated. No, don't. Alright, so 2n minus 1, from here I took 2 common. These are all products only, so that's what 2 into n minus 1, and nothing is left, nothing is left. Chalo. Now because of that, n minus 1, finish, n. These are all products, multiplications only, no addition, so we can remove. So 2 2s are 4, 2n minus 1 by n minus 2 is equal to 11 by 1. Let's simplify, cross multiply. Okay, I'll just do this. N minus 2, 4 into 2n minus 1 into 1. 11n minus 22, 8n minus 4. 11n minus 8n is equal to minus 4 plus 22. Alright, okay. So far, so good, I guess. 8, 9, 10, 11. Count your fingers always. 18. 19, 20, 21, 22. So n will be 18 by 3. That's of course how much? 6. So the value of our n is 6. Okay. Alright, so that's job done for combinations. Alright, let's solve one more problem. And then we can move on to the shortcuts, maybe. I'll give you the shortcut, okay? We have a very big problem which can be very interesting for you to solve. So let's just solve that problem, okay? Have patience. If n plus 1 CR plus 1 is to NCR, this value is 11 is to 6. 11 is to 6, and the other condition is NCR is to n minus 1 CR minus 1 is equal to, these are good practice, okay, good practice questions. Then the question is find n and r, find n and r. Got it? So this is a big question, so this will be the last question, and definitely after this I am going to give you the shortcut, which is really going to be very, very useful. What is this, man? Okay. Alright, so thanks for being with me so far. Please, the students who have been with me till now, please, you can comment in the section below your name so that I will also know. And then I'm very thankful to all of you for having the patience to watch the video. That just shows how strong you are, and then how patient you are with and how interested you are with learning. So please, till now, how many students have been watching this video? Please, I thank all of you. Please do let me know. You can in the comment section below. Please do, you can let me know who watched. Okay. All right. So let's continue then. Now let's take use of the condition. Make use of the condition. What an English, wow. Take use. Wow. Okay, I'm going to write directly so as to save some time also. So this ratio is 11 by 6. 11 by 6. I'm not going to use any theorems, okay? I'm going to just do brute, raw mathematics, okay? So no theorems. I know some of the theorems we can use. I'm not going to use. Let's just expand and see, okay? Alright, let's begin then. N plus 1 factorial. So NCR formula is n factorial r factorial into n minus r factorial. Please be careful, okay? Please be careful. Into, I'm not going to write, let me write so that there is no confusion. Because those students who have been patient, definitely I am sure you will be patient. So let's take our own time and solve. 11 by 6. Okay? Alright, I don't want to move that side, so I'm going to rub this part. Okay? This part and this part, which we have already used. So that will be n plus 1 factorial upon r plus 1 factorial n plus 1 minus r minus 1. This is where many students mess up. Careful, n minus r. What is n? N plus 1. What is r? R plus 1. Okay, na? You can see, na? Okay. Into, so मैं इसको ऊपर ले जाऊँ, r factorial n minus r factorial by n factorial. I think we'll have a lot to do here. Alright, so 1, 1, get out. I'm going to rub this part because I'm done with this. I believe you're also done. Chalo. Now n plus 1 I'll expand so that I can get n. So n plus 1, next will be n. Isn't that we know that it keeps on reducing. So I'll just sort things out. R plus 1 I'll reduce so that I'll get r. So that means r I will not expand, this one I'll expand. So r plus 1, r factorial. And this is n minus r factorial. This is n minus r factorial. This is n factorial. 11 by 6. Let's see what jayega. R factorial, r factorial. N minus r, n minus r. N. Wow, so many things reduced. This is r plus 1. So we'll have 6. I'm going to just cross multiply of what is left. I'm trying to save some time also. R plus 1. 6n plus 6. 11r plus 11. 6n is equal to 11r plus 11 minus 6. 6n is equal to 11r plus 5. Let it be as it is. We will see how to use this equation later on. That is 11r plus 5. Alright, let's keep this somewhere so that I don't have to come back. 6n is 11r plus 5. Okay, that was equation 1. Are you done? You can pause the video there. Okay, after that, I'm going to wrap up. Let's take the other condition. And NCR upon n minus 1 CR minus 1. 6 by 3. This is 2. Now this one I'm going to expand directly. N factorial r factorial n minus r factorial. I'm going to just save some time by just directly that division part I'm not doing. Okay, direct mar did I. So that will be, I hope I don't make mistakes. N minus 1 factorial r minus 1 factorial n minus 1 minus r minus 1 factorial is equal to 2 upon 1. Got that? Now the denominator part, as I did, that one I'm not doing. I'm just doing the direct multiplication, just direct simplification part, because this is down, n minus 1, this will go up. Chalo. And this one I'll expand in advance. N minus 1 factorial by r also I'll expand so that I'll reach there. R minus 1 factorial n minus r factorial into, this is okay, r minus 1. This will be okay, n minus 1 minus r plus 1 factorial by n minus 1 factorial 2 by 1. N minus 1, n minus 1, and what did I do here? R minus 1, r minus 1. That's done so far. N by r into n minus r factorial into 1 cancels, so we have n minus r factorial by 1 is equal to 2 by 1. So this also gayab. No? Okay, you can pause the video. Chalo, I'm rubbing it off. Alright, so we have n by r is equal to 2 by 1, that is n is equal to 2r. Equation 2. So maybe now we can solve this equation 1 and 2 and substitute the value of n in equation 1 and then find out the value of r. And from there we can get the value of n. So like from 1 we'll have 6 into 2r is equal to 11r plus 5. 12r minus 11r equal to 5. That is r is equal to 5. So we have the value of r that is equal to 5. So from equation 2, n is directly 2r, that is 10. Alright, so that was a very interesting problem we solved. So the value of r and n we get very comfortably. Simple mathematics. Alright, so you can pause the video for those who have done. Okay, I'm going to round off now. Alright, now the time comes to give you a small trick. It's not big, that fancy part is one. It's very handy. Okay, it's very handy. So ready? Okay, now you see combinations. For example, let's go back to that 36C4. Usual way of expanding. What do I have to do? Chalo, 36 factorial by 4 factorial. 36 minus 4 factorial. I get 36 factorial by 4 factorial. 32 factorial. So there I have 36 into 35 into 34 into 33 into 32 factorial. You got that, no? Divided by 4 factorial into 32 factorial. Cancel. We have 36 into 35 into 34 into 33 by 4 into 3 into 2 into 1. Holy bapre. Now for big problems, who is going to expand that? So for 1, 2, 3, 4, 5, boom. What we can do is 36C4. I'll tell you what to do. Okay? That's the solution. We're going there only. I just showed this so that if you do not believe me, at least you will see the proof and then you will say, take it. No? For combinations, if you're in a hurry, it's a big problem. No, you don't want to expand. You can do one thing. That is, when you have 30, for example, no, 36C4, you expand 36 4 times. Of course, sequence factorial notation, so it will decrease 1 each. Isn't it? 36, 35, 34, 33, 4 times. 36 into 35 into 34 into 33 divided by, go for the factorial of 4. 4 into 3 into 2 into 1 down. It's all the same. 36. What you do? Got that, no? Another example. This time I'm not going for the proof. Okay, I've already shown you the proof, so spare me the proof. 10C7. Now there are two ways in which you can expand this 10C7. I'll show you both the ways. Okay, so 10C7. As per this, what do I do? Expand 10 7 times, not decreasing order. No, 10 7 times. So 10, 9, 8, 7, 6, 5, 4. So 10, 9, 8, 7, 6, 5, 4. How many times did I expand? 1, 2, 3, 4, 5, 6, 7. 7 times. And continue with this factorial of 7. 7, 6, 5, 4, 3, 2, 1. Or you can use one of the theorem, that is 10C7 if you don't want to expand. Even that also, if you're lazy, then fine, I'll make your job more easier again. That is 10C7, if you remember the formula, that is NCR, complementary combinations, NCN minus R. So 10C7 can also be written as 10C, 10 minus 7. 3, because 7 plus 3 is 10, isn't it? Complementary. So that you will have to expand less times, that is 3 times expand 10. 10, 9, 8. 10, 9, 8. Continue with the factorial of 3. 3, 2, 1. Bus. Simple as that. I hope you've got what I meant. So this is the trick that I was talking about, which is very, very useful. Okay, so you can see expanding all this. Alright, so last practice. That is, let's take up 100 C98. Now 100 C98, instead of going for 98 times, bapre, how, that's all the same. What do? We take the help of complementary angles. So instead of 100 C98, I will use 100 C2, because 100 C98, so 100 minus 98, that is 100 C2, because 98 plus 2 is 100. Again, the concept of complementary combinations. No? 98. So what value on 98 will give me 100? 2. 98, 99, 100. So 100 C2. Or in other words, that formula, NC, 100 minus 98, NC2. And that will be easier for me to expand. So this time I'll expand 100 how many times? Only 2 times. 100, 99. 100 into 99, and denominator I'll just go for the factorial of this 2 only, so that's like 2 into 1. Okay, na? Bas na? So that's why I always say watch the videos till the end. Only for the patient students, everything is easy. Okay, alright then, so thanks for watching so far. So this is the combination. So next video we will be solving some problems from the exercises. So stay tuned. Please do share with all your friends who are facing problems to learn. Facing problems for a source to learn. Okay. All right then. Thank you. Till then, take care. Bye bye.